I am Dr. Loganathan, Department of Mathematics, S.A.E. Engineering College. Today we are going to see the correlation and regression. First we see the correlation. Correlation is the relation between the two variables. It's a number. Okay, the correlation is the summarize the relationship between the two variables in a single number is called the correlation coefficient. Correlation coefficient represented by a symbol small letter R or sometimes use the capital letter R. So it ranges from -1 to +1. So sometimes the correlation coefficient close to 0 means it's a little correlated or no correlation between the two variables. The correlation coefficient close to +1 means it's a positive correlation between the two variables with the increase in one of the variables being associated with the increase in the other variable. The correlation coefficient close to -1 indicates the negative relationship between the two variables with the increase in one of the variable being associated with a decrease in the other variables. So, four type of the correlation coefficient method is available. The first one is the scatter diagram. Scatter diagram is the graphical representation. Graphical means a point is the plotted in the graph with each point represents x and the y variables. Okay. The first one is the positive correlation. Here x is the increase and y is the both x and y are increase. So the first one is the strong correlation. The second one is the weakly positive correlation. Here x and y are the increase, both x and y are increase, but some point is the distance from the straight line. Okay. The next one is the strong negative correlation. Strong negative correlation means some x is the increase, y is the decrease. Okay. So here x is the increase, this point x is the increase and y is the decrease point. Here y is the increase, x is the decrease. So the first one is the both x and y are two variables are increase. So the first one is the strong correlation, strong positive correlation. The third one is the strong negative correlated. This is the weakly correlated. This is the moderate negative correlated. Okay. So this is the no correlated. Here each point they spread the all the area. Okay. Is not represent make a straight line. Okay. So this is the no correlation. The first one is the positive correlation. The third one is the strong negative correlation. Here both x and y are increase. Here both x and x is increase, then y is decrease. So this is the negative correlator, this is the first strong positive correlator. Okay. So some examples for the strong positive correlator. So weight is increase, so a variable x is the some weight, then y is the height. So when height is increase, then weight is increase. So this example is the positive correlated. So height is increase means automatically weight is the increase. So x and weight and height are the correlated. Okay. So this is the positive correlator examples. Some more example. So some temperature is increase. Some temperature is increase means then water consumption is also increase. This is the positive correlation. So the negative correlation means the alcohol consumption. So alcohol consumption is increase means increase, then automatically the driving abilities is the decrease. So this is the alcohol consumption increase means driving ability it's a decreases. So this is the example for the negative correlator. Okay. So this is the example for the correlation coefficient type. The first one is the scatter diagram. Scatter diagram is the graphical representation. The graphical representation does not identify the degrees and degrees here. This is the correlation method. Here using the correlation method, this method is provide the degrees of correlated. Okay, so we find the value of R, okay, with the direction. So the correlation method gives the degrees of correlated with the direction. So this is the example for the correlation method. This is the mathematical application. The scatter diagram is the graphical representation. Okay, so this problem, the correlation coefficient between advertisement expenses and sales volume. Okay, using correlation method. Here correlated two variable. The first one variable is the advertisement expenses. So and sales volume is the sales volume is the another variable. Okay, so advertisement expenses is given. So here from is 1 to 10, that means observation value, number of observation is the 10 each one. So advertisement of expenses values are given, the first one. The second one, the sales volume is the 50 50 55 60 65 65 65 60 60 are the sales volume of the corresponding value of advertisement expenses. Okay, so this is this problem gives the 10 observation. The form is 1 to up to 10 value. Okay, the correlation coefficient formula is the R equal to, R is the correlation coefficient symbol. Okay, so R equal to summation of xy divided by root of summation of x squared into summation of y squared. Here x equal to x minus x bar, y equal to y minus y bar. Here using the deviation formula. Okay, so the form is given 10 value. Here x is the advertisement expenses. So the x column is the advertisement expenses and y is the sales volume. Okay, so x and y's are given. So summation of x. So this formula using x and y. So here x equal to x minus x bar. X bar is the mean value of x and y bar is the mean value of y. So first we find the mean value of x. So x bar equal to summation of x divided by number of observation. Summation of x equal to 140. So number of observation 10. So 140 divided by 10 equal to 14. This is the mean value of x. The next we need y value. Y mean value. So y bar equal to summation of y divided by n. Here we find a summation of y equal to 580. So 580 divided by 10 is equal to 58. This is the mean value of sales volume. Okay, sales volume mean equal to 58. So the next we find x. So x equal to x minus x bar. So x bar is finded. So x bar equal to 14. So x value is equal to 11, 13, 14, 16, 16, 15, 15, 14, 13, 13. So x bar equal to 14. So 11 minus 14 equal to minus 3. 13 minus 14 equal to minus 1. 14 minus 14 0. 16 minus 14 plus 2. 16 minus 14 equal to plus 2. 15 minus 14 1. 15 minus 14 1. 14 minus 14 0. 13 minus 14 minus 1. 13 minus 14 minus 1. So here we need summation of xy and summation of x squared and y squared. So we find x. So we need x squared. So x squared equal to the x. So x value is find out. So x squared equal to minus 3 squared equal to 9. 1 squared 1. 0 squared 0. 2 squared 4. 2 squared 4. 1 squared 1. 1 squared 1. 0 squared 0. Minus 1 squared plus 1. Minus 1 squared plus 1. So we need explanation summation of x squared. So summation of x squared equal to 22. So next we need y. So y equal to y minus y bar. So y values is given. So y bar equal to 58. So 50 minus 58 equal to minus 8. So each value likely this. So we get the value of y value. So here we need again one summation of y squared. So summation of y squared equal to square of y value. So 8 squared equal to 64. So 8 squared 64. 3 squared 9. 2 squared 4. 7 squared 49. 49. 49. 4. 4. 64. So we need a summation of y squared. So adding this value, so we get summation of y squared. So summation of y squared equal to 360. Next we need a summation of xy. Okay, so summation, so we also find the x and y value. So a summation of xy means x into y. So each x into y, minus 3 into minus 8 equal to, so minus into minus plus 24. So minus 1 into minus 8 plus 8, 0 into minus 3 0, 2 into 2 4, 2 into 7 14, 1 into 7 7, 1 into 7 7, 0 into 2 0, minus 1 to 2 minus 2, minus 1 into minus 8, so minus into minus plus 8. So we need a summation of xy. So xy is a binder. So summation of xy is at the last column. So we get the summation of xy value equal to 70. So r equal to summation of xy divided by root of summation of x squared into summation of y squared. So summation of xy equal to 70. 70 divided by root of summation of x squared equal to 22. So 22 into summation of y squared equal to 360. So 22 into 360 equal to 70 divided by 88.99. So 70 divided by 88 equal to 0.7866. So correlation range is the minus 1 to plus 1. Okay, here value equal to 0.78 between the range of minus 1 to plus 1. So it is a correlated. Okay, this is a positive correlator. This is a positive value. So x and y are correlated with a positive correlated. So its degree equal to 0.78. Next, Spearman rank correlation coefficient. So this formula equal to r equal to 1 minus 6 into summation of d square divided by n cube minus n. Here d equal to difference of the rank between the pair of items. So d equal to difference of the two ranks. Okay, so n is the number of pairs of ranks. So example, find out the Spearman coefficient of correlation between the two kind of assessment of graduate students performance in a college. So name of the students A to I, internal exam equal to 51 to 60, external exam equal to 49 to 35. So this is the data. So here observation equal to 9 observation is given. So 9 internal exam value is given, external exam value 9 exam value is given, both are equal. So n equal to 9 value. The next one, solution. So the given 9 observation are given A to I. So name of the students A to I is given. So internal exam 51, 68, 73, 46, 50, 65, 47, 36, 60. Here only two exams are given. So internal exam 1, external exam 1. The rank of internal exam is first one. Here highest value is the 73 is the 1. The next highest value 68 is the rank 2. The next one 65 3. The next one 60 4th rank. This is the 5th rank, this is the 6th rank, this is the 7th rank, 8th rank, 9th rank. Suppose two values are equal. So again 68, again 68 means this is the second place, the next one is the third place. So rank is given 2 plus 3 divided by 2. So 2 plus 3 5, 5 divided by 2. So each one is the 2.5. So next one the second exam, external exam mark is given. So here rank is the first one is the 174 is the first rank, second rank 72, third rank 66, fourth rank 58, fifth rank 50, sixth rank 49, seventh rank 44, eighth rank 35, ninth rank 30. So ranks are given. So mark is given. So here we find out the ranks. So rank 1, rank 2. So the formula is the Spearman rank correlation formula equal to R equal to 1 minus 6 into summation of d square divided by n cube minus n. Here d is the difference of two ranks. So rank 1, rank 2. So different is this. So here we find we need differentiation of rank, and n is the number of observation. Here n equal to 9. So number of observation 9. So next we need D. D equal to differentiation of two rank, R1, R2. So R1 is the first name A equal to rank in the internal exam 5, in external exam 49. Here rank is 6. So 6 minus 5 equal to minus 1. Okay, so 5 minus 6 equal to minus 1. So second one 2 minus 2 0, 1 minus 1 0, 8 minus 7 1, 6 minus 4 2, 3 minus 3 0, 7 minus 5 2, 9 minus 9 0, 4 minus 8 is equal to minus 4. So d squared equal to, we need d square. So d square equal to 1 squared 1 0 0, 1 2 squared 4 0 4 0, 4 squared 16. So we need summation of d squared. So summation of d squared equal to sum of the last column is equal to 26. So summation of d squared equal to 26. So rank equal to 1 minus 6 into summation of d squared divided by n cube minus n equal to 1 minus 6 into summation of d squared equal to, we find. So summation of d squared equal to 26. So 6 into 26 divided by 9 cube minus 9. Okay, so here n equal to number of observation 9. So 9 cube minus 9. So n is equal to 1 minus 6 into 26 equal to 156 divided by 9 cube 729 minus of 9. So is equal to 1 minus 156 divided by 720. So is equal to 1 minus 0.2167. So it is equal to 0.7833. So this is the correlation coefficient value, R equal to 0.7833. So this is the range between the, this is the positive correlation between the minus 1 to plus 1. This is the nearest to the close one. So 0.7833. So this is the positive correlation. This is a positive correlation with the degree equal to 0.7833. With this direction is the positive direction. So next example, here the previous problem we considered the two internal exam mark and the external examination mark. Here three competitors are given. So here 10 competitors are given. Here 3 judges are available. Okay, so the 10 competitors in a beauty contest are ranked by the 3 judges in the following order. So here 10 competitors are given the judges of the beauty contest. So first judge given the rank of first person 1. So the second judge given the third rank. The third judge given the first one 6th rank. So each person gave the 3 ranks. Okay, so use the rank correlation coefficient to determine which pair of judges have the nearest approach to the common taste in the beauty. So which one gives the nearest, that means the positive correlation value given, that judges is the best common taste in the beautiful. Okay, which gives the, so next solution. So okay, given. So in order to find out which pair of judges have the nearest approach, so here the previous problem given the 2 examination. Here so 2 examination, so 2 ranks are find out. Here 3 judges are given. So 3 judges given the each one having the rank, put the rank. So rank by the first judges are given in the 10%. So each one, the first judge given the first one columns, the second one gives the rank of second one, the third one rank of third one. So here we find out the common taste in the beauty. This is the find out value. So to find the common taste in the beauty, so we compare the first judge and the second judge. The second one is the second judge and the third judge. The third one is the first judge and the third judge. So first differences are first judge and the second one. So R1 minus R2. So different second difference are R2 minus R3. The third difference are R1 and so the Spearman rank correlation we need a differentiation of R1 and R2. So first we find the differentiation of D1, D2, D3. So D1 is the differentiation of R1 minus R2. So R1 is the 1, R2 is the 3. So R1 is the 1, R2 is the 3. So 1 minus 3 equal to minus 2. Minus 2 squared. Here we find the D squared value. So minus 2 squared is equal to 4. The next one, 6 minus 5 equal to plus 1. So 1 squared 1. The third one, 5 minus 8 minus 3. So minus 3 squared equal to minus 9. So continue this, so we get the D1 square value. Next to find the second difference means the judge 2 and judge 3. So D squared equal to R2 minus R3 squared. So R2 equal to 3. So 3 minus 6. So minus 3 squared equal to plus 9. This is the second one, D2 square. The third one, D3 squared equal to rank 1 minus rank 3. So rank 1 is the judge 1, rank 2 is the give the judge 2, judge 3. So 1 minus 6 equal to minus 5 equal to minus 5 squared equal to 25. So number of observation, each one equal to n equal to 10. So each one equal to same, both are same. So 10 ranks are available. So summation of D1 squared equal to 200, summation of D2 squared equal to 214, summation of D3 squared equal to 60. So here we find the common taste of the two judges. So first judge and the second judge given the rank correlation coefficient R equal to using the Spearman rank correlation formula 1 minus 6 summation of D1 squared divided by n cube minus n1. So 1 minus 6 into summation of D1 squared equal to 200. So summation of D1 squared equal to 200. So 6 into 200 divided by each one number of observation equal to 10. So 10 cube minus 10. So 1 minus 1200 divided by 990 is equal to minus 0.2121. So this gives the negative degree. This is the negative correlated. So correlated value minus 0.2. Okay, so degree value is the minus 0.2121. It gives the negative correlated. So this is the not possible. The second one is the second judge and the third judge. So R equal to 1 minus 6 into summation of D2 square. D2 means judge 2 and judge 3. So D equal to R2 minus R3. So 1 minus 6 into summation of D2 squared equal to 214. So 6 into 214 divided by 10 cube minus 10 is equal to 1 minus 1284 divided by 990 is equal to minus 0.297. So which gives the negative correlated value. The last one is the first judge and the third judge. So R equal to 1 minus 6 into summation of D squared divided by n cube minus n is equal to 1 minus 6 into here D3 squared equal to 60. Okay, so here put the value of d3 squared 6 into 60 divided by 10 cube minus 10. So you see it gives the 0.6364. This gives the positive value. This is the positive correlation with the degree equal to 0.6364. So this judgment is the first judge and the third judge is the common test are given. Okay. So this one is the positive correlated. So the answer is the first judge and third judge are given the same test of purity contest. So next one, regression. So what is regression? So correlation means the relation between the two variables x and y. Here x and y are not both are equal. Okay. So here regression is the statistical method used in the finance, investing and other disciplines that attempts to determine the strength and character of the relationship. Here listen, strength and character of the relationship between the development of between a dependent variable and one or more independent variable. Here strength and character of the relationship between the dependent variable and the independent variable. So the correlation is that both are equal, both are independent variable or dependent variable. Here relationship between dependent variable and independent variable. Okay. So dependent variable and one independent variable means simple regression. Okay. So more than one independent variable means it is the multiple regression. We find the regression coefficient means we find a regression line. We first find the regression line. So the first one is the regression line of y on x. This lines gives the probable value of y. So y is the dependent variable for any given value of x. So any given value means this x is the independent variable. So regression line of y on x is the equation y minus y bar equal to byx. This is the regression coefficient byx into x minus x bar, or y equal to a plus bx. This equation is the regression line of y on x. Regression line of x on y. Here x is the dependent variable and y is the independent variable. So the regression line of x on y equal to x minus x bar equal to bxy. The previous one is the byx, here bxy. So x minus x bar equal to bxy into y minus y bar, or x equal to a plus by. Here x is the dependent variable, y is the independent variable, here b is the slope of the equation. So three types are given. The first method using the correlation coefficient. So r is given and standard deviation given means we find the regression coefficient x on y, that means bxy. So bxy equal to r is given, standard deviation is given. So standard deviation sigma x is given and sigma y is given. So bxy equal to r into sigma x divided by sigma y. Here regression coefficient y on x means byx equal to r into sigma y by sigma x. The directed method using the sum of x and y. So the given value we add the x and y value. So bxy equal to n capital N is the number of observation. So capital N summation of xy minus summation of x into summation of y divided by capital N summation y square minus summation y the whole square. So bxy, y on x equal to, this is a direct method. So we find summation of xy, summation of x and summation of x squared, summation of y squared. So n into summation of xy minus summation of x into summation of y divided by n into summation of x squared minus summation x the whole square. The last one, here we use the deviation method when deviations are taken from the arithmetic mean. So arithmetic mean means x bar equal to summation x by n. So bxy equal to summation of xy divided by summation of y squared, where x equal to x minus x bar and y equal to y minus y bar. So regression coefficient of y on x with using the deviation method. So x equal to x minus x bar and y equal to y minus bar. So correlation regression coefficient b yx equal to summation xy divided by summation x square. Here summation y square, here summation of x square. The denominator is the different. So we find the regression equation y on x or regression line x equal to some a plus by. So we find first we find the a and b value. So here using x and y r values are given. So x on y. So first we find the normal equation summation of x equal to na plus b into summation of y. So summation of xy equal to a into summation of y plus b into summation of y square. This is the only x on y. So y on x means summation of y equal to na plus b into summation of x. Summation of xy equal to a into summation of x plus b into summation of x square. So this is the example. The following data is given the age and blood pressure of 10 sports person. So name is the A to J. So age is given. Second data. So that means x. Blood pressure y equal to data is given. The first question is the find the regression equation of y on x. First we find the regression equation of y on x and x on y using the method of deviation arithmetic mean. The last one method. The second one is the find the correlation coefficient using the regression coefficient. So first we find the regression coefficient, then next we use the apply the correlation coefficient formula. So name is given A to J. So 10 observation is the given. So age is given, second column. Third column blood pressure is given. Here using the deviation method. So first find the mean value of x and mean value of y. So x bar equal to summation of x by n. So summation of x equal to 500. So 500 divided by n 10 equal to 50. So next we find y bar equal to summation of y divided by n is equal to 1000 divided by 10 is equal to 100. So regression coefficient formula is equal to, so x on y bxy equal to summation of xy divided by summation of y square. So y on x equal to summation of xy divided by summation of x square, where here x equal to x minus x bar and y equal to y minus y bar. Here x is the mean value of x, y bar equal to mean value of y. So we find summation of xy, summation of x squared and summation of y square. So first find the regression coefficient of x on y. So bxy equal to summation of xy divided by summation of y squared. So here, so also find the summation of xy value equal to minus 128. So summation of xy equal to minus 128 divided by summation of y squared equal to 1120. So divided by this equal to minus 0.1143. So next find the regression coefficient of y on x. The formula equal to, so byx equal to summation of xy divided by summation of x square is equal to, so summation of xy equal to 128 divided by 904. So value is the negative value. So regression equation of x on y. So x minus x bar is equal to bxy into y minus y bar. So equation is the regression equation x on y equal to x minus x bar equal to bxy into y minus y bar. So also find the mean value of x and also find the regression coefficient of x on y and mean value of y value is also find. So using this formula, so x minus x bar equal to 50 is equal to bxy equal to, so also find minus 0.1143 into y minus y bar equal to 100. So finally we get x equal to 61.43 minus 0.1143 y. So 0.1143 is the slope value. So the next one, the regression equation of y on x is, so y minus y bar equal to byx into x minus x bar. So also find the y bar and byx and x bar. So y bar value is equal to 100, so y minus 100 equal to byx equal to minus 0.1416 into x minus x bar equal to 50. So finally we get y equal to 107.08 minus 0.1416 into x. So slope value is equal to 0.1416. So the last one is the computation of coefficient of correlation using the regression coefficient. So also find the regression coefficient. The relation of correlation coefficient are equal to root of regression coefficient of x on y into regression coefficient of y on x. So it's equal to minus root of value is the given, so 0.1143 into 0.1416 is equal to minus 0.1217. If this gives the negative correlation, it's close to 0. So degree of the correlation coefficient is equal to minus 0.1272. Is the negative correlator. Okay, thank you. See you the next section.